Today we are going to do section 7.3 on page 714, where we are dealing with systems of equations where they are not just straight lines. So far we have done two equations, two unknowns that are just both straight lines, or three equations, three unknowns, again planes, which are also straight. Okay, so now we're going to deal with something that's more complicated, but only two equations and two unknowns. However, the two equations are not straight lines. For example, let's say we have a parabola. This is on page 714. You have a parabola, and we want to know when the parabola intersects with some straight line. The problem is they might not even intersect at all if they are located in such a way that they don't touch each other, like this picture. Or they might intersect, but only at exactly one point. Okay, they just barely touched. Or they can intersect at 2 points. That's the most they'll intersect if you're talking about a parabola. But with other kinds of graphs, they might even intersect at more than 2 points. But whatever it is, we're going to trap down the intersection and crank it up, basically using the same method. So let's look at example 1 on this page, where we're solving this system of equations. Let me write it down. So we have two equations here, x minus y equals to -1, and y equals x squared plus 1. Okay, so I'm going to call it equation 1 and equation 2. Now the fastest way is probably, well, I already said y equals x squared plus 1, so let's stick y right in here. Okay, that is, replace y with x squared plus 1. So starting with equation 1, I will write down x minus y, okay, equal to -1, where y is x squared plus 1 according to equation 2. Right? Yeah, I think so. So then we have this situation, which this is a quadratic equation, right? Because you have x squared and some x and then some numbers. And therefore we will have, I'll write it, the x's on this side because x squared is negative, see? So I'll move it over here so that it's positive. So I have x squared, and then the x is positive, so it becomes negative on this side. And then the number is, let's see, what is this? This is -1. Okay, move it over here, and here's another -1, so a total of -2, and that equals to 0. And the reason I'm doing this, because we know how to solve this kind of thing, okay? And there is a way to pull this trick, or alternatively, we can always use a quadratic formula if all else fails. So this thing can be solved no matter what. So in this case, however, I think it comes out pretty easy. We need two numbers that multiply to be -2 and add up to be -1. So that should be -2 times +1 should do it, because -2 times +1 is -2, and then -2 plus +1 is -1. And so that works out, and that gives us then this is 0. So that gives us x is -1 when you set this equal to 0, or x equal to 2 when you set x minus 2 equal to 0. And if x is and that's about it. However, we need to figure out what y is. Y is y equals to x squared plus 1. So from equation 2, we get, if x is -1, y is x squared plus 1, that makes it y equal to 1 plus 1 is 2. And then if x is 2, that's 4 plus 1, that's 5. So in this case, y equal to 5. So these are the two pairs of solutions for this problem that should work out. Okay, so let's look at the answer. And what does it say? Let's see. It says x equal to 0. What? 0, 1, and 1, 2. Yep, I'm afraid I messed up somewhere. Let me check to see where I messed up. All right, I messed up on one of the numbers. See, x right here. This is -1, okay? Moved over here is +1, so it's not -2, it's 0. Let me erase this stuff. All right, try again. Okay, -1 moved over here becomes +1, so this is 0. So all we have is x squared and minus x left. That's even easier yet. So we have then we have then this is equal to 0. Okay, it's just x times x minus 1. So x then from here is x equal to 0, and from here x minus 1 equal to 0 or x equal to minus 1. No, sorry, 1. And then and then y, if x is 0, right here, y, it will be equal to 1. Y equals to 1, and if x is 1, y will be 2. Y equals to 2, and these are the set of answers. All right, now let's see. So x equal to y equals to 1 and 2, and x equals to 0 and 1. And that's it. And on the following page, we see the graph of these two curves. They happen to intersect at 2 points. All right, and that is the solution. So next, let's look at example 2 on page 716. Now we have this thing at this equation, x squared plus y squared equal to 5, and y equals to 3x minus 5. Now we have never done things like this, okay? The book calls this thing a circle, but we have never learned about circles or how to plot it or anything like that. However, at this point, that information is not relevant to us. We'll just plug it in and solve it like we always do. Being that I already said y equals 3x minus 5, we'll put y right in here. Okay, so let's so this will be equation 1, and we'll put y into equation 1 and get this. So we have x squared, okay, plus y squared, and that equals to 5, and y is 3x minus 5. We'll write it in there. And then, so now what's left here is to solve a quadratic equation that was done in, I think, chapter 2, I believe. And so please review the chapter to how to solve quadratic equations if you're rusty about it. And then what we're going to do now is just, well, we're going to crank it out. Okay, there's nothing else to do. So we'll write down x squared. We need to multiply this thing out, which is 9x squared minus 3 times 5 is 15, times 2 is 30, 30x, and then plus 25 equals to 5. Okay, there is to do what I just did there is a formula for it that is which is called a plus b squared. Squared. A plus b squared equals to a squared plus 2ab plus b squared. All right, I'm using that formula, but you can do that, or you can just write it out the normal way and multiply it out however you can. Okay, this has to come to here, some way, one way or another. Okay, so next let's do sum up this stuff. So we have 10x squared minus 30x plus 25 plus move this back here, that becomes 20, right? 25 plus minus 5. All right, and by the way, I forgot to mention that in problem 1, the book went about it a different way than I did, and that doesn't matter. Okay, we can plug y into x, x into y, whichever way that feels good to you, as long as you get the answer. Okay, and so that, and in this case, however, there's well, you can isolate x and then plug it in here if you want. So either way, but the y is already isolated, so why work harder than you have to? And so that's what we are doing right now. All right, so we have this thing, and these have a common factor of 5, so we'll reduce it. Divide everything by 5 to make it simpler. So we have, after dividing by 5, then we have 10 divided by 5, which is 2. So we have 2x squared, 6x plus, divide by 5, that would be 4, right? Okay. No, that was not good enough, because I still have the even numbers. Should have divided by 10. Well, anyway, so let's divide by 2 now. Or originally, I should have divided by 10. I don't know why I didn't. Okay, so this is x squared minus 3x plus 2. That's the simplify thing if I had divided by 10 in the beginning or divide by 2 right here. Either way, we get this. And factoring this thing, we need two numbers such that when they multiply by each other, they equal to 2. So it has to be 1 and 2. But when they're added together, they have to be -3. So they must be -1 and -2. Because -1 plus -2 is -3. -1 times -2 is +2. And so that is how we solve this kind of thing. And now, anyway, so from here, x minus 1 equal to 0. That gives us x equal to 1. X minus 2 equal to 0 gives us x equal to 2. If x is 1, then y, according to this formula, is y equal to, here's 1 here, 3 minus 5, that's minus 2. And then if x is 2 in here, that becomes 6 minus 5. 6 minus 5 should be 1. And that should be the answer to example 2. X equal to 1, okay? Next page, y equal to 1, y equal to 2. Okay, the answer is 2, 1, and 1, -2. All right. Now, if you were to graph this thing in the graphics calculator, you will see something that looks like what the book shows on the following page. Okay, some line cutting across some circle. Now, the fact that x squared plus y squared happens to be a circle, we haven't learned that, but that is we're not worried about that right now. Okay, we just use the same trick. We don't care if it's a circle or not. Just and that will calculate the intersection for us immediately. So let me clean off the board. So next, let's look at page 718, example 3, where we are solving equations where we have a bunch of squares. That again, the book calls this thing a circle and this thing an ellipse. But again, we don't care about that right now, what kind of shape it really is. We only care, we'll just use the same old trick and to find out where they intersect. Now, so the problem is x squared plus y squared equals to 26. 3x squared plus 25y squared equals to 100. All right, so let's do that. Now, being that everything is being squared, okay, we can pretend we'll solve for the squares first. Then we'll take the square root of them once we got the squares figured out. Okay, so this will be called so this basically works like a linear equation, like section 1 basically. And what we're going to do is we'll isolate one of these things. So x squared equal to 26 minus y squared from this equation, okay, equation 1. And then once we know that, we'll plug x squared into equation 2, this one. So to write it down, we're plugging x squared in here, okay. So 3x squared, right, plus 25y squared, okay, following this thing, equals to 100. And that means we'll plug x squared in terms of y in there. That's 26 minus y squared. All right, so then now we just have like a quadratic equation with y squared being the new item that we're squaring. So to do that, we have to multiply this thing out, which is which is not going to be fun, but there's no getting out of it. So what is this? That would be 3 times, we'll multiply the whole thing like, do we have to do that? Yeah. Anyway, so 3 times 26 squared, okay, minus 26 times 2, that's 52, 52y squared, and then plus y squared, and then squared again, and then plus 2y squared, and then minus 100. Minus 100. I moved 100 to the other side, and that gives us to be 0. Now I did this multiplication that's with a formula similar to this. That is, there's a formula that says a minus b squared that equals to a squared minus 2ab plus b squared. Okay, that is a formula from chapter 1. So please look this up, or just multiply this out the regular way. Either way, okay. And so the formula probably make it a little faster. So then, but either way works, whatever works for you. And so we have this thing, and now we have to add stuff up. Okay, first we'll find the highest power. This is y squared squared. So we will write that down. Well, remember, right now we're treating y squared as one variable, like x. Okay, so this thing is like saying x squared. And then, so there's minus 52 plus 2, that's minus 50 y squared. And then finally, we have this thing. What is this thing minus 100? Let's calculate that right now on the calculator, which we have. All right, I will type in. We'll type in 3 times 26 raised to the power 2. Okay, like this, and then minus 100. No, I forgot to get off. 2, get down. I need to get out of the exponent. Then type in minus 100. Okay, like this, and then that equals to. What? Seriously? Okay. I guess that makes sense. And then what is this anyway? Plus. All right. Plus 1928. That equals to 0. So anyway, let me, before I go any farther, let me see what the book says. Well, the book doesn't have this big of a number. Let me check to see what the book did. Maybe we should do it their way so that the numbers are not so big. Well, but before we do that, I think I found a mistake in here. Okay, it's 3x squared plus 25y squared. I'm missing a 5 here. 5. Okay, and then so that would make things somewhat different. We have plus 25y squared, and then that's plus 25. Okay, and so then is minus 52 plus 25. That is different from that. So that makes it, instead of minus 50, we'll have minus, this is a 5 here. Minus 52 plus 25, that's minus 27 y squared. And then the other stuff is probably correct. Let me check this again. Sorry, I got confused over here. So let's try again from this point. Okay, so we're applying this in here. I said 3x squared. I don't have to, I squared it again. What a waste. So let's not do that. So 3x squared is 2y minus y squared. That's it, 26. 26 minus y squared. Okay, 3 times this thing, plus 25y squared. That equals to 100. All right, so then, so then we have a total of 3 times 26, okay? 3 times 26 minus 3y squared plus 25, that's plus 22y squared, okay? Then minus 100. Actually, we don't have to do minus 100. Equals to 100. And so then, okay, let me check. So then 22y squared equals to 100 minus 75 plus 3, 78. Okay, 3 times 26, yeah, should be 78. And which is equal, 100 minus 78, that is 22, which means y squared equals to 1. That's much better, isn't it? Okay, now the book did a different trick. They multiplied this equation by 3 and then subtracted the 2, and it works out identically. Okay, the process is almost the same. So you can do that one or this one. It makes no difference. So anyway, we have this situation. Y squared equals to 1. Y squared equals to 1 means y can be positive 1 or negative 1. Okay, and we'll write it together in one sentence because we're lazy. I'm lazy. So we write it as y equals to positive 1 or y equals to negative 1. But that's what this sentence means, is two sentences combined in one for people who don't want to write two sentences. So y is equal to positive 1 or y equals to negative 1. Now in that case, let's see. Actually, I think I better write it in two sentences. So I'll write it over here. Okay, y equal to positive 1 or y equals to negative 1. Now if y equal to positive 1 or negative 1, what is x then? X then equals to x equals to this, okay? Whether y is positive 1 or negative 1, x will be equal to 26 minus y squared. So x squared equals to so let's see, where should I write that? Right here, okay? X squared equal to 26 minus 1 squared, right? Y is 1, so that equals to 25, which means that x equals to positive or negative 5. Okay, then that means x can be x equal to positive 5 or x equal to negative 5. But how does that match up? The way it matches up is that all four combinations work. That is, we have four pairs of points, either x equal to 1, y equal to 1, that is which is the point 1 comma 1, or let me get rid of this thing here. Or the next option, x equals to 1, y equals to minus 1, which is the 1 minus 1 point. Okay, notice that these 2 points, because the reason these are solutions is when you plug it in here, whether it's a positive or negative, everything got squared. So it all works out anyway, okay, no matter what you do, which is why all combinations work. So next, we have x equal to minus 1, y equal to positive 1, and that gives we minus 1 comma 1 point, okay? And finally, x equal to minus 1, y equal to positive 1, also negative 1, so we get this point. In other words, there are, if we were to graph these 4 points, this is positive 1, minus 1, minus 1, positive 1, and minus 1, and minus positive minus 1. So you have these 4 points on the graph, where this is the x-axis and y-axis, and all 4 points are intersecting these two graphs. See, and the reason, so it's not just the answer. So we have 4 answers instead of 2 because there's so many squares here. Okay, so then and they all match up. X can be positive or negative, y can be positive or negative, and when you plug them in, they all get squared and turned into positive anyway. So that's why this solution happens this problem happens to have 4 solutions. So that is that. Now, if you were to graph it, which you don't need to in this case, graph it on the graphics calculator, then you see why that is. The 2 equations look like that, and that's why they intersect 4 times. Why does it say 5? Oh, sorry. X is 5. Why did I think x is 1? X is 5. All right. But besides being 5, everything I said works. Okay. Just change the x value from 1 to 5. So these are 5s. 5, 5, 5. All right. So yeah, something like that. Positive or negative 5. So that is what this stuff looks like. And again, the fact that these equations are circles and ellipses, you don't have to worry about that right now because we haven't covered that yet. We are just, without even knowing what they are, we're still able to calculate where they intersect. Okay, and so that is so that's that. Let me erase the board. Next, let's go to page 719, where we look at inequalities. Now, and the graphing of the inequalities look something like this. We have some pictures of inequalities here, but I will show you how it's done. Let's say we take a simple such as y equals to x squared minus minus 4, okay? And let's say we graph this thing. If we are to graph this thing, we get something like, why am I not able to draw vertical lines there? So if we were to graph this thing, then it looks something like this, a parabola, okay, where x is 0, y is minus 4, is down there is minus 4. And so what about it? The point is, however, this is the equation y is equal to x squared minus 4, and then anything above it, then y will be bigger. And down here y is less. So what if I want you to graph y is bigger than x squared minus 4? Then what you do is that your entire plane now got separated in 3 regions here, okay, and then crossing the parabola, okay, and then where it's equal, and then down here. Now, which part is bigger than and which part is less than? You pick a convenient point to test it. If that point is bigger, then the whole area here is bigger. So let's test 0, 0. At 0 and 0, if y is 0, okay, then and x is 0, so then it's minus 4. Well, 0 is bigger than minus 4, which means this part is y is bigger. So this is the area in this whole area here is where y is bigger than x squared plus 4 minus 4, our equation. And out here, everything out here is y is less than x squared minus 4. And that's how you plot inequality graphs. They're all they're all like this. And exactly on the line is where y is equal to x squared minus 4. Okay, so you just pick some convenient point, doesn't matter where, that's on above the graph or on the other side of the graph, and then cross the river, pick a different convenient point. Maybe here, maybe here. Usually some point on the axis, because on the axis one of the coordinates is 0, so make the calculation slightly easier, and then figure out if it's how that works. So that's how you calculate, how you graph something that is bigger than 0 or less than 0. Now the book has, of course, the examples drawn here. Let's see, what is that? This is y is bigger than x squared equal to 4. Okay, this is, let's see, what is that
anyway?
Okay, this is the second one. If you look at your book, this graph is harder to see. This is less than, this is bigger than or equal to. So you slap an equal sign there. So this one, the line here is dotted. The reason it's dotted is just so that to mean that that line is not included, okay? Because we're only talking about bigger than, we're not talking about equal. So this line is solid because we're talking about bigger than and equal to, y is bigger than or equal to x squared minus 4. And the other side is if y is less, the same principle applies. This is strictly less than x squared minus 4, so you have the dotted line, or it's less than or equal to, which means it's the dotted line, it's the solid line, plus all the area underneath, okay? Everywhere underneath it, and that's shaded here is where it's less than. So with that, let's look at the next example. So next, let's look at example 4 on page 720, where we have the questions to graph this thing. Okay, y bigger than x squared plus 1. So first, to graph any inequality, we first graph the equality. That is y equal to x squared plus 1. Okay, let's graph this thing. What does that look like? Well, that thing, you can do a quick graph. Okay, this is a parabola where when x is 0, y is equal to 1. So the parabola goes this way, and here's the 1 part, and then it goes up because the coefficient is positive. So your parabola looks something like this. Okay, and that is a good enough graph for our purposes right now. You don't have to type it into the calculator for something like this. And so now the question is, what if it's bigger? Then we just pick, well, bigger normally use y is on top, right? But to be sure, we can say, what is, let's pick a point in here and see what happens. Like, let's say this point would be, since this is 1, okay, let's say this point is 2. In other words, this point is x equal to 0, y equals to 2. Now, if that is the case, when x is 0 and y is 2, So 2, and then this is 1. So how does that relate? If x is 0 and that side becomes 1 and y is 2, then the equality holds, right? 2 is bigger than 1. So therefore, the entire region is this area for y bigger than x squared plus 1. And I'm sure your book has a nice picture here. Yeah? Okay, so that is the graph as shown by the book. See, they did the same thing. Is they tested a point 0, 2, and to make sure that it is bigger, then y is bigger there at that point, and therefore it is the bigger, that would be the answer to the region. So that when it's bigger, then it's not just, the answer isn't just one point, it's the entire region. The whole shaded area is the answer to your problem. All right, so that is that, and let's look at the next problem. So next, let's look at example 5, where we're supposed to graph both of these equations. That is, we need to graph the area where both situations happen at the same time. That is, x squared minus y has to be less than 0, but 2x squared plus y has to be less than 12 as well. So to graph this thing, let's just, well, we can do a rough draft. Actually, let's not bother, okay? Let's type this thing into the Desmos calculator, because well, the book wants you to calculate their intersection. I don't know why. It just wants to graph. We don't care where they intersect, really. So let's graph this thing. And once you graph it, then, so if you type it into the Desmos calculator, you will get something that looks like this, okay? And you just type in the first line, and the Desmos will give you some color. And when you push this thing, which is a button, the graph will disappear. Push it again, it will appear. That's in case you don't want to see it for the moment, okay? And same with here. So I typed it in, and it types in exactly as you see. Well, the exponent, you might not remember how to type in the exponent. To type in the exponent, you use the up. I don't know what that thing is called. Is let's see, it's the button over the number 6. That is, you push the shift button and push 6 right here. Push 6 either at the same time, or keep the shift down and then push 6 and then let go. And then that will move the cursor up, and so that you can type the power number 2 in there. Okay, and then yeah, so that is how you type in the power. So once you push in a 2, then you continue to push negative sign. The negative sign will show up immediately without you having to move the cursor down. If your cursor is stuck on top, like stuck in the power position, right? And to move it down, you can just use the mouse to move it somewhere else. Or if that doesn't work, use one of these things. Okay, just push the right arrow, and that should drop the cursor down. So anyway, that is how you type stuff into the Desmos calculator. Now, once you type this in, then we know what the graph looks like, right? And then we need to figure out what region is that, because these are just the equalities, okay? Then we just have to find out which region this is talking about. Now, the first one, the Desmos graph show that the graph of the first equation, x squared minus y equal to 0, is the parabola. Okay, it's just the standard one. It's the y equal to x squared parabola. Okay, and but we need x squared minus y to be less than 0. Well, okay, let's try anything in here. Say 1. Okay, this is the point 0, 1. Right? Okay, now does x squared minus y less than 0 in this area? Yes or no? Okay, if the answer is yes, then that's the area we're talking about. So 0 minus 1 is less than 0. Therefore, yes, this is the area we want. Okay, I'll shade it lightly here. So that is what that is. Secondly, this graph, as it shows, is something like this. See, I have it looks something like that, right? And what area will satisfy this? We'll pick any point to check it. In fact, we'll check 0, 1 again. Okay, so if x is 0 and y is 1, is it less than 12? The answer is yes. So the entire equation that satisfies this is down here. I'll shade it like this. So for both situations to happen, the intersection point, this chunk in here, is our answer. All right, that is should be it. And of course, being that it's the one detail is if it says less than or equal to, that means the boundary is included in the answer. That is, the boundary is solid. If it doesn't say less than or equal to, if it only says less than, then it will be the dotted point situation. Dotted point just means the boundary is not included. Yeah, something like that. Anyway, so that would be our answer. Now, in the plotting, now I want you to plot this in your Desmos calculator, or if you don't have access to this, the Desmos for some reason, but you do have the graphing calculator like this thing, and you're stuck with doing this, then please graph it on this if that's your only option. Okay, or if for some reason you have to do it. So, and figure out how to use that thing, because that thing's a real pain. So good luck to you. I'm not going to talk about it because, yeah. But on the Desmos calculator, after you have typed this stuff in, okay, and then the Desmos will show you that beautiful graph, not the ugly thing that the unfortunate people will be stuck with staring at in TI-84 or some such matter. So I want you to go to the side of Desmos, okay, that is, let's see, this is the equation as part, okay, move, and look at the other side of the screen, you will see this, this thing right up here. You see the little wrench? You click it and this thing will pop out, okay? If you click it again, it will disappear. So this thing will give you some control on it. I want you to change the x-axis values, which is right now, you know, whatever it is now. I want you to change it to this part to -5 and that part to +5. If you do that, the graph will stretch and look wider, okay? And to me, better looking, okay? This is too narrow. This is way too skinny, you see. I mean, it's yeah. This is proportional, in the sense that, see, the 5 here, from 0 to 5 is the same as from 0 to 5 up. But then the graph looks too skinny that way. If you change it here to something like that, then the graph will look much nicer and wider and fill up the whole screen and more pleasant to the eye. Okay, that is. That I want you to do that because it gives you more experience on using Desmos, and also remember, if the graph is sitting over here and in your way and you want to move it, you just push the mouse down, keep it down, and drag it over here. Well, similar to what I'm doing on the screen, but this is just a screenshot, so it doesn't work. But that is doing what I similar doing, you know, drag the graph and it'll move wherever you want. And also in Desmos, there's a magnifying and reducing button, the plus sign. If you click the plus sign, it will zoom in, okay, and get bigger and bigger, and push minus sign, it'll zoom back out. And so on. So this is far easier than the TI-84, though I suppose if you're stuck with doing TI-84, it's not so bad, because that will help you appreciate Desmos much more, okay? If you have never touched TI-84, you might not know how wonderful the Desmos is. You might think that the whole world has been this wonderful since the beginning, and you have no idea what people had to put up with back before Desmos when they were stuck with the TI-84. So anyway, so that is, this is this, okay? That is the end of this example, I believe. Okay. So we have come to the end of this section. Please do the examples yourself. And also for homework on page 722, please do problems 9, 13, 17, 19, 23, 27, 29, 33, 35, 39, 41, 46, 47, 49, 53, and 55. And when you're done, I want to talk about most of them. I know that sounds like more homework than normal, but the systems of equations is a very important skill to have. Well, because solving equations is a very important skill to have, so it's important that you do enough homework in this section to solidify your understanding and skills in solving equations. Even though they're not always that much fun to do, okay, it's worth your time. Now that you're done with homework, let's do problem 13. problem 13 is a very convenient problem. You see, there's a plus 4y squared minus 4y squared, nicely, conveniently lined up for us. So let's just add these two things up, okay? Adding equation 1 to equation 2, we get 2x and 2x, so that is 4x squared. And then that disappears, and then that equals to 25x right here, this one. And then 4 minus 10 is minus 6. Or right on the same side, we have 4x squared minus 25x plus 16 equals to 0. Okay, now I'm afraid this is where our happiness ends. Because, yeah, x equal to, well, maybe it's okay. I'm not sure. What? Let me think. First, let me fix my mistake. This is 4 minus 10. That's minus 6. Why do I have 16 there? I thought I said minus 6, didn't I? Yeah, and so that, let's get rid of that. That is, okay, so that makes life much better. And why is there a plus? Didn't I have a minus there? Yeah. So how did that change to a plus? Oh, that because I moved over. So that part is okay. That's better. All right. So let me think. It's fine. There's no need to think. All right. So to pull this trick, okay, if this trick doesn't work, then we got to pop out the quadratic formula. Now, but right now, I think it's still okay. So we have 4x, we have to create 25. So we have 4 times 6 is 24, and then one more is 25. So see, and then, but this has to be negative, so we'll have minus 6 and minus 1. That will become minus x, okay, and then minus 4 times 6, that's together is that becomes negative 25, while minus 1 times minus 6 is still positive 6. So we're good. So that gives us x equal from here, x equal to 1/4, okay, and this gives us x equal to 6. Now x equal to 6 is going to be a problem because right here, it says 2x squared plus something equals to 4. If x is 6, no way is 2x squared going to be equal to 4 because everything here is positive. You notice there's a square on the y, okay, square on the x. So this, so if this is bigger than 4, there's no way this equation can hold. So x equal to 6 is rejected as a solution because 6 squared is way too big to go way above 4, so that is not acceptable. So x equal to 1/4, which when we plug it in, that does that even work? Yeah, that depends on what y is. So we'll figure out y from this solution. So if x is equal to 1/4, let's see how we can come out. So that is equal to 2x squared. Is x just equal to 1/4? Yeah. So anyway, if x is equal to 1/4, then plugging it into here, we get 2 times 1/4 squared. That's 1/16. Okay. So that is that plus 4y squared. That equals to 4. So that will mean that 4y squared will be equal to 4 minus, this is 1/8, okay, 1/8, and then so y equal to y squared, then equal to this whole thing divided by 4, which is 1 minus, well, we'll do this on the calculator, actually, instead of messing around with it. It actually equals 1 minus 32. That would be 31 over 32 or something. But maybe I should just do it on the calculator to be clear. So to do it on the calculator, as always, let's put parentheses on it because we're dividing by a difference. Okay, these things divide by 4. So let's put it in parentheses. And otherwise, the calculator will get confused. So let's do that. So we have 4 divided by, what? No, sorry. Again, parentheses, 4 minus 1 divided by 8, close parentheses, okay, 4 minus 1 divided by 8, and then divided by 4, all right? That equals to 31 over 32. Okay, so that way y squared equals to 31 over 32. And then so y is the square root of that. Right, so y equals to, y then equal to the square root of 31 over 32. And let's slap. But that y can be positive or negative though, 32. Okay, because if y squared is that, so either the positive or the negative one will work. Okay, now the book answer says that says something different. It says that the book calls it square root of 62 over 8. Okay, now I will have you figure out why these two are the same thing. Okay, now if you have trouble with that, please go over the radicals section, how to do radicals in chapter 1. But this is the same as this one, because if you multiply by 2 both sides, it's then it becomes 62 over square root of 64, which square root is 8. So please work this out yourself if that is if that sounds confusing, or you're not sure how to do that. So these are the same thing. This is the same as plus or minus. Yeah, some quick manipulation of radicals will give it to you. If you have trouble with it, then just take this subtracted by that. E equals to 0. Okay, if it's equal to 0, they're the same. So that would be the answer. So the answer is that x equal to 1/4 and y equal to the plus value, or x equal to 1/4 and y equal to the negative value. So that you have 2 points in the answer. I should probably write that out to be clear. So here are the answers. First is 1/4 comma square root of 62 over 8. That's the first answer. And then 1/4 comma negative square root of 62 over 8. All right, so there are these things represent 2 points. So whatever these things are, they intersect at 2 points only. All right, so that's problem 13. So next, let's do problem 17, where we have these two very interesting looking stuff. They look almost the same, right? But there's a square there, and that's the trick. So we are going to avoid the square for now, because there's a simple y there in both cases. So let's do that, okay? Here's equation 1 and equation 2. So we'll pull the same simple trick of multiplying, say, equation 1 by -1. The reason is times, okay? I'll use that symbol for times. Equation 1 times -1. Now if we do that, we'll change the sign across the board, and then when we add it to equation 2, we'll eliminate y completely. So that's what we're going to do. So that have x squared, okay, minus y, changing signs, equals to -2. All right, so we'll call that equation 3. And let's add equation 3 to equation 2. So these two being added together, we have x squared minus x, x squared minus x, y disappears, and that equal to 0. And that makes a very easy solution to solve, right? That means x times x times 1 minus 1 equal to 0. And that gives us x equal to 0. So x is 0, or x equal to 1 for this one. 0 and x equal to 1 here. And so then y, from this equation, y is 2. From equation 2, we get y equals to 2 plus x, right? Move the x to the other side. Y equal to 2 plus x, which means that when x is 0, y has to be 2. So y is 2 here. That's the first solution. X is equal to 0, y equal to 2. And when x is 1, then y should be 3. So y equal to 3 it will be the second solution for when x is equal to 1. So there is that should be our 2 points. What is this? Problem 17. Yep. So we have 0, 2, and 1, 3. That is correct. See, an easy problem, so to speak. Next, let's do problem 19. We have x squared plus y squared equal to 1, and y equals to negative x squared. So then when you stare at this thing, try to find a weak point to attack. Now, if we were to plug x squared in here, then the whole equation will be y in terms of y, right? So then you got rid of all the x's. So let's do that. We have, from this equation, we get x squared, moving it over here, x squared equal to minus, well, this is getting worse. Let me erase that. All right, try again. Now we have, so from here, we get x squared equals to minus y, okay? Put x squared on this side, put y on the other side, and you get this. Let's plug it in here. We have then minus y, okay, plus y squared, and then and minus 1 equal to 0. And that, we'll write it another way, is y squared minus y minus 1 equal to 0. That is, now let me see. That is not good. And not good. We're still on doing the right thing. It's just that doesn't have a very neat, comfortable, clean answer. So we're stuck with using the good old quadratic formula. Okay, there is no way around this because there's only minus 1 here. So that thing where you write 2 parentheses is not going to work. There's not enough. We need, like, I don't know, anything. We need something else, like I don't know, 2, some kind of 2 maybe. Well, whatever. The point is we don't have it. Okay, so let's not dream about what we don't have and work with this thing. So let's pull out the quadratic formula. Please memorize the quadratic formula if you haven't done so. The quadratic formula is called minus b plus or minus square root of b squared minus 4ac all over 2a. So that's what we're going to do right now. Okay, if you haven't memorized that, please do so right this moment. Okay, all students of mine know how to recite the quadratic formula. So by the quadratic formula, the number here is a, b, and c. So minus b plus or minus square root of b squared minus 4 times a times c, and the whole thing divided by 2 times a. A is just 1, so I won't write that out. And now we're going to need to do this, and I have to do it without messing up my negative signs. So 1 plus or minus square root of 1 minus plus 4. 1 plus 4, and divide by 2, and that should be the value for y. And then x, y, what's x? X is equal to x squared equals to minus y, okay? So x equals to square root of minus y. So x equals to square root of negative y, and that would be, so x equals to this, let me see. So this is, let's see. Let me look at this. Okay, now being that x equals the square root of negative y, the negative y needs to be positive. In other words, this thing, so what is y anyway? Let's calculate minus y, okay? So minus y equals, to stick a minus sign here, minus 1, and then we have a plus. Let's write down the plus 1. Plus 1 plus 5 is 6, and then the whole thing divided by 2, and the square root sign extends all the way over the 2, which is fine. Now there's also a negative 1 right here, right? But we can't do that because if it's negative, then the whole thing inside the square root will be negative, and we're not accepting We don't give about complex numbers at this point. So we'll keep it positive because the square root of 6 is going to be bigger than 1, so this will be a positive value, and we can take the square root thereof. So x is equals the square root of, this is just x squared. So x equals to plus or minus square root of y, right? Because x squared equals to negative y, so x equals to plus or minus. So x is plus or minus of this thing, and that is our answer. Now let's write the answer out to be clear what we're talking about. So x is equal to this value or that value, whereas y equal to, we rejected the one where y has a, let's see, this is minus y, okay? So y is the other one. Now, all right, so I should write down which y value we accepted. So y equal to 1 minus square root of 1 plus, and 6, square root of 6. 1 minus 6 divided by 2. All right, we rejected the plus one because we need y to be negative. If y is negative, negative y will be positive. And we need the stuff under the square root sign to be positive, and which is y. We chose the negative value for y. Because 1 minus square root of 6 will be a negative value, and we slap a negative sign on there, it will make it positive so the x can survive. Okay, so that is, so this is the value of y, and then this is the value of x. So we have one value of y and two choices of x, so that gives us two answers, and which I will write down, I will write it down right now. So here are the two answers I wrote down. Now the first one is the x when it's positive outside the square root. Okay, so we have the positive one. Y value is as written here. And the second answer is x is the same thing except that with a negative sign. So the negative one, and y value is the same in both cases. Now this might look a bit confusing, okay, because we're talking about reject, especially this part and this part. Please stare at this thing until it makes sense, okay? If you find it confusing, look at it very, very carefully and spend a few minutes staring at it until the whole thing clears up for you. Because remember, x equal to this, and y, for this thing to be positive, it has a negative sign in front, which means y needs to be negative, and that's the only confusing part, I think. And then x end up having two choices, so the two choices are here, where y, the choice of y, it applies for each choice of x. That's why we have two answers. And that's the end of problem 19. So next, let's look at problem 23. We have 2x cubed minus x squared equals to y, and then x squared plus y equals to 0. Okay, now we are going to, being that there is only one y here and one y here, let's put the y, get rid of y, okay, by let's see, well, by rewriting this equation. This is the equation, rewriting this thing as x squared equal to minus y, and then we'll just add up 1 and 2. Okay, if we add up 1 and 2, we get 2x cubed. Okay, this becomes 0, right? And y and minus 1 also becomes 0. See, x and minus x becomes 0. And so then that equal to 0. So it means that x has to be equal to 0. And then if x is 0, then very quickly you notice that x squared plus y is 0. So that gives us y equal to 0. And that should be our answer for problem 23. Yep, that is correct. X is 0, y is 0. So next, let's look at problem 27. But before that, I want to remind you of this formula. This is called the difference of squares, where a squared minus b squared factors into a plus b times a minus b. Now these formulas should be in your cheat sheet. Okay, you should have a sheet of formulas that comes in handy that you can refer to if you can't remember them. Probably that you just remember them, but if you can't remember them, then the cheat sheet is the second best option. So we're going to apply this formula right here as difference of squares formula to this thing, the first equation. So we'll rewrite the first equation as equation 1, and then which becomes x plus y times x minus y, and that equals to 9. All right. And then this is equation 2. And then we'll plug x minus y equal to 0 in here. Okay? So then x plus y times 0, which is 0. So this side is completely 0 because that's 0 here. 0 equals to 9, which is not possible. Okay? This is called a contradiction. 0 is not possible to be 9. So so what does that mean? That means this problem has no solution due to 0 becomes, if there's a solution to it, 0 has to equal to 9. That's not possible. Therefore no solution. Okay? That is the answer to problem 27. So next, let's do problem 29. Minus x squared plus y equal to 2, 2y equals to minus x. All right, so to do that, let's take equation 1 and multiply it by minus 2. Yeah, because I want to knock out the 2y here. Okay, so here's equation 1, and then let's take equation 1 multiplied by negative 2. So that it looks like this one. Well, that part does. So we have 2x squared, okay, minus 2y equals to minus 4, right? We're multiplying by minus 2, right? So then we add these two things together, and we get 2x squared, okay? The y's disappear, and then equal to, that side becomes minus x, and then minus 4. Or write it another way, 2x squared plus x plus 4 equals to 0. And that does not look good to me. I don't think we can pull that factoring trick. I think we're going to get our good old quadratic formula again. Okay? And remember, what is the quadratic formula? It says, the quadratic formula says that x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So that is what we're going to do here. So x equal to minus 1, that's the b, okay, plus minus b squared, which is 1, minus 4a, and c, that's 4, all over 2a. 2a is 4, right? And so look at this part in here. This part under the square root sign is called the discriminant. Now you have 1 minus something all positive, right? And that's a number that's much bigger than 1, which means we're taking the square root sign of a negative number. And we're not accepting complex numbers right now. So there is no solution to this problem, period. So the answer to this problem is no solution. So next, let's do problem 33. We have 3x squared minus y squared equals to 12, x minus 1 squared plus y squared equals to 1. Okay, so let's do that. Now to do that, there's a conveniently minus and a plus sign in front of y squared, so let's just add it up. Okay, adding equation 1 to equation 2, we get just x's left. 3x squared plus x minus 1 squared, and the y's disappear, so 12 plus 1 is 13. Okay, so that's good. Next, we need to multiply this thing out. So that would be, we'll use this formula right here, okay? And then that would give us 3x squared plus x squared minus 2x plus 1, okay? And then that equal, and then minus 13. We'll move the 13 over to become minus 13, and that equals to 0. And so finally we get 4x squared minus 2x, okay? And then that will be minus 12 equal to 0. And so that makes, simplify that. So that's 2x minus 2x squared minus x. That is minus 6 equal to 0. All right, so then this, let me see. So we are going to do this. This should work. Okay, this looks better. Don't know if it, don't know for sure until we try. We need to make some number. This has to be 2x, okay? And this has to be x. And then this multiplied together, it has to become 6, and then added to become 1. So something, let's see. How would that work exactly? Let's see. Let me think about it, okay? Yeah, well, this is well, we have, let's try 2 times 3, okay? We have, let's have, well, we try different things, such as 3, I'm not sure. How would, what's the best way? Well, if we try 1 times 6, that is not going to work. 2 times 6 is 12. Okay, that's too much. And we're not going to get minus 1 that way. So what about 6 and 1? Then we have 2 times 1, and then that's 2. 6, that's still too much. How about 2 and 3? If we have 2 and 3, 2 times 2 is 4, and that will create 1 if there's a 3. That will work, okay? So that is better. And well, this process, if it gets too tedious, it might be better just pull out the quadratic formula. But anyway, this thing seems to work. So we'll have a 3 and 2 here. And specifically, we need this number to be minus. They have to be different signs. So it will be a minus 2 and a plus 3. That should come out. Okay, so as a result, we will have x equals, from here, we get x equal to minus 3 over 2, okay, when you set this equal to 0. And from here, we get x equal to 2. All right, so that is that. And then we need to, from each x, we need to calculate what possible y's there are. Okay, so let me move over here. Plugging in, we'll do the easy one first, where x equal to 2. Now, so y, if x equal to 2, then plugging it into equation 2, okay? From equation 2, plugging in with x equal to 2, we get 2 minus 1, that becomes 1, okay? 1 plus y squared equals to 1. That means y equal to 0, right? So that means, so y equal to 0 out of that. So when x is 2, y is 0. All right. So that is the first solution. And then the other solution is x equal to minus 3/2. If that is the case, we have plugging again into equation 2. So equation 2, plugging in x equal to negative 3/2. Now if that is the case, we have minus 3/2, okay, minus 1 squared plus y squared equals to 1. Now, yeah, watch this very carefully. Now, this number is bigger, minus 3/2 and then minus 1. That is like minus 5/2. When it's squared, so this is negative 5/2. Okay, when you square it, that will be, this number is bigger than 1. Right, and then when you square it, it's still bigger than 1. It's 25 over 4. And so it's much bigger than 1, and it becomes positive when you square it. So when you plus a positive number, there's no way that it can become 1, because it's too big. See, big number, add a positive number, has to become 1 for some reason. So then this is not possible, so this solution is rejected. Okay, so only this solution is accepted. That is, the answer is x equal to 2 and y equal to 0, and that's it. That's the only answer that's useful, and that is what the end of the book says as well. Now I will finish this section in the next video.